All right, so I'm going to click on 9.5 Inheritance Hierarchies, and you can do the same and kind of read along with me here. Let me set up my note sheet as well, I suppose. This is, let's see, Inheritance Hierarchies. Inheritance Hierarchies. And if you want to write down what section it is, it's 9.5. And today is February 18th. Oh, I didn't get to ask about Valentine's plans. That's okay. That's okay. I hope you all had a wonderful Valentine's or Galentine's or whatever you guys do there. It was sad. I'm sorry. Valentine's Day is overrated. I just celebrate my love every day, so it's hard. It's hard. Like being a hopeless romantic like me, it's just like another day. Okay, so what is an inheritance hierarchy? We should probably maybe define it and draw a little picture really quick before we get into what we need to do here. I'll just do that. Inheritance hierarchy. My definition is basically several classes that inherit from each other. I'm going to leave a little bit of room here on the left so I can draw out like a picture of an inheritance hierarchy. We always use shape. What's another inheritance hierarchy we could come up with? Say it again? Classes in schools. So there's like classes, and then there's like regular, then there's like AP class, honors class. Say it? Subject. Oh, we could, okay, and then you could do like they have a subject. I like it. How about we do, so let's draw one out. How about this? So you've got, I'm going to call it school class. I'll just draw this out. School class, that's my like super class. And then maybe I have other classes that inherit from it. And maybe there's like, let's see here. Maybe there's AP class. That inherits from school class. And you could have like online, online class. They still call it a class, right? Okay. Sorry, no offense to online classes. You got a low grade in an online class? Oh, well, what was it, Daniel, 98? I'm kidding. Oh, got him. And then, I don't know, you could have whatever. Wait, how can we add regular class or something? No, we don't even need regular class. Hold up. What could we add to this inheritance hierarchy? Is there something that could inherit from online class or from AP class? I mean, you could have an individual class, sure. You could have... Oh, here's what you could do. AP class. Like us, we're a 2-try AP. So maybe I could say 2-try AP or something like that, where that is a subclass of AP class. Hey, Abby. So something like that. That would be an inheritance hierarchy. Some relationships to note here. Let's see. An AP class is a school class. An online class is a school class. A 2-try AP class is an AP class, is a school class. So, you know, you could write some of those down if you wanted to. You could make questions out of this hierarchy. But that itself is a hierarchy. And maybe I can say some of these relationships. Let's see. You could do school class. Well, this is kind of boring. School class is a school class. Dadoy. You could say something like AP class is a school class. And you could even say something like 2-try AP is an AP class. I don't know, maybe I'll put an and is a school class because it's in that hierarchy. The thing you want to look at in this hierarchy, if you've never taken a biology class or anything like that, anything under the umbrella is a. So even though 2 Tri AP does not directly inherit from school class, it still is a school class because it's under the umbrella. 2 Tri AP is an AP class, an AP class is a school class, so 2 Tri AP is a school class. Does this all make sense so far? Oh, did you need a pass?
Yeah, that's okay.
Where are you going?
Pike.
Okay, let me pause the recording here. All right, we're back. Any questions on this hierarchy? Does it make sense? Okay. Now, some things that you can do in a hierarchy. I'm going to put in a little section here, declaring and instantiating. Declaring and instantiating in a hierarchy. In a hierarchy. Oh, did I mark John absent? I don't know. So some things, basically when you are declaring and instantiating in a hierarchy, you can do something like this. Superclass, let's say, I don't know, object name equals new subclass you can do something like that. Technically, you could also do just or new superclass as well. Both of those are legal. So you could say, so when you're declaring and instantiating an object, you can declare it as a superclass object and then say equals new subclass, or you could say superclass object equals new and then the same class again. So just for some examples here of what's legal. Let's see. Examples of what's legal. Let's do, how about, we'll use our hierarchy up here. I could do school class. I don't know. What's a school class? Where'd you guys just come from? Orchestra, sure. Now, I'm just going to say that's a regular school class. So this is totally fine. That is okay. You could also do school class. Let's see, what's an AP class? Gosh, stats, AP stat equals, oh, that's technically a 2 Tri AP as well. Whoops, that's okay. New 2 Tri AP. That is totally legal as well because 2 Tri AP is a school class. Basically, when you're declaring and instantiating, you can do it as long as it passes the ISA test. Is a school class a school class? Yes. Is a true 2 Tri AP a school class? Yes. And then maybe one more example. Wait, let's put in a bad example, something that's illegal. Anybody think they can give me an illegal example that doesn't follow the ISA rule? Like I reverse them. Yeah, you got an idea, Eli?
Online class is an AP class.
Perfect. Psst. If there's an online class that's an AP class, I would be. Let's see. Which subject do I want to trash here? AP. I don't want to trash anybody. Everybody's good. AP knitting. Nothing's wrong with knitting. I want that to be clear. If you knit and you're listening to this at home, please don't be offended. There's nothing wrong with knitting. Equals new school. What'd you say, new AP class? Yeah, that would be totally illegal. Is that what I called it? Good. Okay. So I'm going to make a little note to myself that that is totally illegal. Maybe I should have written in a different color. That's okay. So this last example is illegal. Illegal, doesn't pass the ISA test. Doesn't pass ISA test. An AP class is not an online class. That's not how you spell test, is it? Oh dear. No! No! Stop it. How do I get back? There's got to be a thing. Tell me if you see it. Redo. There we go. Okay, we're back, baby. We're back. Basically, an AP class is not an online class, so that would be illegal. Does that make sense? Okay. Now, why would you do all of this? That's a great question. Why? if methods are overridden in the subclass, you will use the method body from the class on the right. Now, there's other ways that I can state this, but in the examples up here, when I made obj name, you will use any method body from subclass because it's created with subclass's constructor. When I made orchestra, you'll use any of the methods that are in the school class because it's created using the school class's constructor. When I made AP stat, it'll use any overridden methods that are in 2-try AP because it was created with 2-try AP's constructor. However, if it doesn't override any of the methods, it'll just use the ones that it inherits from school class. Does that kind of make sense so far, at least? So, for example, there might be a method called return, get number of trimesters. Well, obviously 2-try AP is going to override that method and return 2. So if I do AP stat dot get number of trimesters, it'll use the method implementation from the class on the right, 2-try AP. It won't use the method implementation from the class on the left, school class. Am I kind of making sense a little bit? No? You can tell me if I'm not. Say it again? Right meaning, here, I should clarify, Ben. Basically what I'm saying here, when I say the class on the right, I'm trying to say which constructor it was created with. So basically subclass, this one was created with subclass's constructor. This one here, school class, is created with school class's constructor. Can you guys see my pointer when I'm doing this or no? No? Let me try this. Can you see it now? Okay. So OBJ was created with subclass's constructor, so it'll use any of the methods in subclass. Orchestra was created with school class's constructor on the right, so it'll use any of the method implementation in school class. AP stat was created with 2-try AP, so it'll use any method implementation from 2-try AP. Is that better? Does that make more sense? Okay. The other way to say it, from the class on the right or from the class, what did I say? It used its constructor? That's constructor was used? Whose constructor was used? Whose constructor was used? Is that making more sense? Okay. Thank you. Thank you for helping me clarify. You're going to help anybody that listens to this video, all 3 of them. All right. So that's basically what we've learned kind of so far about inheritance hierarchies. Any questions there? Yes, Dana? Can you say it a little louder? That's a great question, Dana. So why would you ever want to declare it like this, right? Basically, why would you want to declare AP stat like I have there? There's not really a good reason why you would declare a single object like that. What we're going to look at today, and we looked at a little bit on Friday, is what if a method wants a school class object? Then I could send in an AP class. I could send in an online class. I could send in a 2-try AP. So you'd probably never do it just for an individual object, but you might do it for like a collection of objects, which we'll look at today, and also when you're passing in parameters. So yeah, it's not very practical to do just by itself. Good question. Anything else? Okay. To review and write down what we did on Friday, I'm going to scroll down just a bit here. Here's what we looked at on Friday, superclass method parameters. It says another advantage of an inheritance hierarchy is that we can write methods with parameters of the superclass type and pass in subclass objects to them. For example, the print shape method below could be called with many different shapes. So if you look at this method, it's expecting a shape. And if you don't remember the inheritance hierarchy, it was like shape, rectangle, square, something like that. So I could pass in a shape object for S. That's totally legal because a shape is a shape. Could I pass in a rectangle object for S? Yeah, a rectangle is a shape. Could I pass in a square object for S? Yes, a square is a shape. So this is another advantage, and it goes back to Dana's wonderful question. You would never probably declare it all by itself, but this means I could send in a rectangle or a square for a method like this, and that's essentially what Java would be doing behind the scenes. It would be saying something like equals, square object or whatever. That's good writing. Thank you. So I'm going to kind of write down this here, superclass method parameters. Where are you? Here we go. So I'm going to write that down in a little section here. Sorry, it's been so long since we've done a lesson like this where I'm talking a lot. I apologize. Superclass method parameters. And basically the idea is if a method requires an object, you can send in an argument of that object's type So, for example, on the example they had, it expected a shape. So I could just send in a shape object, obviously. If it expects a string, well, duh, I'm going to send in a string. But you can go a step further. You can send in an argument of that object's type, or an object that is a subclass of that type. Can I fit it in here? The absolute madman has done it. So that's the whole thing. Usually when a method expects a string, we just send a string. When a method expects a rectangle, here's your rectangle. Do something with it. Method expects a AP class, here's an AP class. But let's say a method expects a shape. We can send in a shape. We can send in a rectangle because a rectangle is a shape. We can send in a square because a square is a shape. Here's a good one. What if a method expects a capital O object? What could we send in? Basically anything. You could send in a string. You could send in a capital I integer. You could send in a person, an AP class, whatever. Because they're all subclasses of object. Yeah, Annie. That's exactly right. I should probably write that down, Annie. I should give this attribution credit to you, an inline citation, but I probably won't. But basically, I'm gonna do anything that passes the ISA test. Annie, I'm not going to write your name down. That way I don't have to share the YouTube revenue with you. Sorry. Oh, gosh, I'm on video admitting to a crime. It's okay. It's all right. Say what? Did you see, I was reading that there's this like scientist that went and copywrote every possible like melody, because he's saying there's only like a limited number of melodies left to songwriters, essentially. So he went and generated every possible melody, I think in like 12 notes or something like that. It's like 68 billion different melodies. And he went and put them out into he open sourced all of them. Hold on, let me pause the recording. You don't believe me. Hold on, 1 second.
What a man.
All right, so anything that passes the ISA test is where we were at. So maybe we should write down just a quick example using the hierarchy that we came up with. So maybe I could do something like public void, I don't know, print class or something. Let's say there's a method like this that expects a school class object named, I don't know, class. And who knows what the method does. Doesn't really matter. I'm trying to get our hierarchy from up above in this frame here. Sorry. So, what type of objects could I send in for class? Let's see, is this legal? Could I do something like print class? Maybe I'll just make an anonymous object really quick. New school class. Would that be legal? Yeah, because a school class is a class. And I could do the same thing for, I'm just going to use ditto marks if that's okay for you. I could do the same thing for an AP class because an AP class is a school class. I could do the same thing for an online class as well. So any object that passes the is a test, like someone in the audience might have said, you can send in for that method. Does that kind of make sense? Cool. Cool. And so, going back to Dana's question from earlier, which was a fantastic question, you would probably never do any of this stuff up here intentionally, where you're creating an object like this. But that's basically what Java does when you send in a object to this method. It's basically saying school class object class is it's now going to be created with AP classes constructor or something like that. Okay? Okay. Now, that's what we talked about on Friday, so I'm not going to go through all this stuff because we did it on Friday. But I am going to go down to 953 because this is the last thing here. So let's look at 953, superclass arrays and array lists. So it says, using inheritance hierarchies, we can create arrays and array lists using the superclass type and put in values that are of the subclass type. This can be very useful. For example, here is a shape array and a shape array list that can hold any objects of the shape subclass. So let me just put the hierarchy on the screen one more time. Shape, rectangle, square. So when I go ahead and declare an array of type shape, anything that is a shape can go in there. So a shape could be sent in. It looks like it was right here. A rectangle could be sent in. It looks like it was right here. A square could be sent in because all of those are shapes. Now if you're looking at the syntax and going, why does it say new? They're just creating an anonymous object and just storing them in there. You could also create the shape on a separate line and then put it in there if you wanted to as well, but they're just shoving in some different shapes, squares, and rectangles there. Similarly, down below here, here's an array list that can contain shapes. So what kind of stuff can I put in that array list? Shapes, obviously. Can I put a rectangle in there? Yeah, a rectangle is a shape. Can I put a square in there? Yes, a square is a shape. All of those pass the is a test. So essentially, anything that is the type that your array or your array list is can be put in that list. So imagine you're going shopping for vegetables. You could put in, oh gosh, we did this the other day and you guys were telling me a bunch of stuff is not vegetable. Let me try this again. Let's say you're going shopping for fruit and you've got a list for all your fruit. Well, you can put a tomato in there. Tomato is a fruit. You can put an apple in there. An apple is a fruit. You can put a cucumber in there. A cucumber is apparently a fruit. Yo-Yo was explaining it to me. She said, like, genetically they're fruits, but then sometimes they're, like, nutritionally they're vegetables. That's how she explained it to me. I don't know if that's right or if she's just telling me a story or what. But, so essentially, whatever you declare your array or array list at, you can put any of that type or subclasses of that type in there. So here we see that we are creating an array of shape objects. You may recall that Java array elements and array list elements must all be the same data type. Yet we see that this array contains a shape, a rectangle, and a square. A shape, a rectangle, and a square when it's only supposed to hold shapes. How is this possible? It's possible because rectangle and square are subclasses of shape. Is that hitting? Is that making sense? Okay. Cool. Question?
This is like what we did with the balls.
Oh my gosh, Ian, you are totally right. We've been doing this for like weeks. now, and we didn't even know it. When we did the ball thing, if you looked at the runner code that I gave you, there was a ball array. What could go in the ball array? Well, obviously a ball could go in there. What else? Big ball, flashing ball, whatever kinds of crazy smiley ball, whatever kinds of nutty balls you guys came up with could all go in there because they were subclasses of ball. Does that make sense? Okay, thank you, Ian. That was a great connection that I should probably be making, and I did not. So, I'm going to write this down, obviously, in my notes here. What did they call the header here? Superclass arrays and array lists. Okay. I know, it's been a lot. It's been a lot. We're almost done with the notes, I promise. Superclass arrays and array lists. Why am I apologizing for having you guys do notes? I'm like teaching. What's wrong with me? Sorry you have to learn now. Okay, so basically, if an array or array list is declared to hold superclass type objects. How can I finish this sentence?
You can chuck in some of the subclasses.
Yeah. What'd you say? Chuck them in? I like it. You can chuck in subclass objects as well. I should be writing that in red. Hold up. Subclass objects too. Now, that doesn't mean you're only going to put subclass objects in there necessarily. You can pass in the same thing. If it's an array of shapes, you can put in just shapes. That's fine. But you can also put in squares and rectangles too. If it's an array list that requires school lists or school classes, we could put in a school class. That's fine. We could put in an AP class. We could put in a 2-try AP. We can put in an online class because they are all school classes. So maybe just one last thing here is putting in our example. Let's do example here. Let's say that, what do you guys want to do, an array or an array list? We haven't done array lists in a minute. We haven't done arrays either in a minute. Array? Okay, so let's do like a school class array. Remember, here's how we do array declaration. We say the type followed by square brackets. This says it's a school class array. Maybe I'll call it classes. Let's do, you guys, anonymous objects you don't like? No? Not a fan? Okay, let's do this then. Let's do this then. New school class. I'll just have it hold two things. So if you don't remember the stuff with arrays, you say the type followed by square brackets. That indicates it's going to be a one-dimensional array. If I want a two-dimensional array of school classes, I could do that too, but I'm just doing a one-dimensional array here. That's why there's one set of square brackets. Then you name the array, and then you say equals new. And in this case, I'm just going to say it's going to hold two things. So this is how I say it's going to hold two things. I could also do list format, where I initializer list, where I put curly braces and put stuff inside of it. So then I could do something like, I'm sorry, I'm still going to use anonymous objects. Whoops. So yeah, I lied. I'm sorry. I could obviously put a school class in here. That's fine, because it's supposed to hold school classes. A school class is a school class. Da-doy. I could also do something like this. School classes sub 1 equals, name a subclass of school class. AP class. I could also do something like this. And that's totally legal because it passes the ISA test, like Annie said earlier. An AP class is a school class, so it can go into an array of school class objects. And then going back to Dana's wonderful question earlier, we would probably never declare just a single AP class object like we did above, where we said school class AP equals new AP class. But here we're saying essentially school class sub 1 is a new AP class. And again, it passes the ISA test. An AP class is a school class. A school class is a school class. I could have put an online class in there. I could have put a 2-try AP in there as well. Questions? It's my Spider-Man. All right. Let's see. Should we look at this example here? Let's just take a quick look at this example. Nope. Yep. Nope. Yep. Okay. It says the code below has an array list of pets that can hold pet or dog objects. Well, let's confirm that this is true. I see a pet has a name and a type. Pet has a constructor. Pet has a toString that says name is a type. So Scruffy is a mutt. I don't know. Scruffy is a dog, I guess I would probably say. Then they make an array list of pet objects. This means that this pet list can hold any type of pet or subclasses of pet. So then they go ahead and add a pet. That's name is Sammy and he's a hamster. Then they try to add Fido. Let's see. Can you add a new dog named Fido? Oh, dog is a pet. So I could add Fido there. I believe it says then go ahead and do it with cats. Are you guys okay with skipping the adding the cats part? Okay. I mean, we could do it. It would literally be this, but it would say cat. Okay, we're fine not doing that. Oh, good question. Oh. Question down here. Which of the following reasons for using an inheritance hierarchy are valid? Let's go through them point by point together and tell me what you think. 1. Object methods from a superclass can be used in a subclass without rewriting or copying code. Is that a good reason to use inheritance? Yeah, I would agree. We inherit any of the public methods that operate on objects, so I think that's a good reason to use inheritance. 2. Objects from subclasses can be passed as arguments to a method that takes an argument of the parent type. What do you think? Yeah. We went over that. If a method expects a shape, you can send a shape, a rectangle, or a square, because a rectangle is a shape, a square is a shape. So that's a good reason. Maybe you're trying to find the perimeter in this method. Both those methods could do that. Or the method could do that with any of those objects, I should say. What about number 3? Objects from subclasses can be stored in the same array of the parent type. Yeah. So I would say 4, all of the above. Are you guys on board? Cool. Okay. Any questions so far? All right. Before we get to this programming challenge, there is a summary at the bottom. I kind of wanted to write some of these down on my notes here. Let's see. An inheritance hierarchy of subclasses inheriting from superclass can be formed with object. I would just write this down. An inheritance hierarchy of subclasses. An inheritance hierarchy is subclasses inheriting. Okay, let's write that down. Summary. An inheritance hierarchy shows the relationship between superclasses and subclasses. Would you agree? Okay. Superclasses and subclasses. Let's see, what else? Subclasses inherit public methods from superclasses. The other 2 points we put up here, superclass methods that require a superclass object That's just not superclass object can also be passed a subclass object. And then arrays and array lists that, sorry, my hand's cramping too. Arrays and array lists that store superclass objects can also store subclass objects. Woo! Okay. So I'll just reread these here. Let me know if I missed anything. An inheritance, I missed the word hierarchy. That's an easy fix here. It's just because I can't spell it. An inheritance hierarchy shows the relationship between superclasses and subclasses. Subclasses inherit public methods from superclasses, even up several levels in the hierarchy. Because remember, if you're a subclass and you inherit from a superclass and that superclass inherits from another superclass, you're going to be inheriting down that hierarchy, down that ancestry line. Methods that require a superclass object can also be passed an object of the subclass type, and arrays and array lists that store superclass objects can also store subclass objects. Did we summarize pretty much everything there? Okay. All right. I'll leave that up for a second. If you're still writing, go ahead and copy it down. If you're not, you can start reading the Programming Challenge 954 because we are going to be doing that. Are you guys good on the notes? Clay, you almost good? Okay. So, this challenge here, it says, the following code contains a class called shopping cart that simulates a grocery store and online store's shopping cart. It has an array list called order that you can use to add items to the shopping cart. The item class keeps track of the name and price of each item. If you run the code below, you will see that it adds 2 items to the cart and then prints out the total order. Let's see if that's true. I got bread for $3.25. Oh, fancy bread. I'm just kidding. Oh, somebody got a whole loaf. Milk for oh, a little upper crusty here. All right. Milk $2.50. That seems right. Subtotal $5.75. No discount. Total is $5.75. Looks like they're in a no tax zone. Okay. In this challenge, you will add a new class called discounted item that extends the item class. The array list of items will still work since it can hold the subclasses of items too. The shopping cart print order method will work with items and discounted items, but note that it has an if statement that treats discounted items differently. I am so curious to see that. Oh, look, they use the instance of operator. If I is an instance of discounted item, so if they pass in a discounted item object, then it'll be treated a little bit differently here. Interesting. In the discounted item subclass, all right, there are 5 things you are going to do. Don't worry about number 6 because we're going to be doing this in JGraphs. Number 1, add an instance variable for the, so you're going to be working in discounted item. Number 1, add an instance variable for the discount amount. You don't need to add the other stuff, the name or the price, because those are inherited from the superclass item. Then it says add constructors that call the superconstructor item. 3 says add getters or setter and setter methods for the discount. The get method is given below, but you should modify it. It's wrong. 4, add a toString method that returns a string that calls that includes a call to the super toString method. That'll print out the price as well as the discount amount using the super.value toString method to format it. Interesting. And then 5, uncomment the code in the main method to test adding discounted items to the cart. Now, instead of you guys worrying about working here and it's not formatting things correctly, don't worry. Mr. Foster's got Mr. Foster's got you. I've got item, discounted item, shopping cart, and shopping cart tester are all there. You are going to copy and paste each one of these four into JGrasp, compile and save them all in the same location. I have already done so, and I wanted to show you that I'm not a liar. I just need to open them. Where's my, hit me with that open recent right now. Recent files, I got item. Hit me with that recent file here. I got shopping cart. Hit me with that recent file. I've got discounted item, and hit me with that recent file. I got shopping cart tester. If you go ahead and compile and save in the same location, there will be no errors yet. What you are going to do is follow those 5 steps, 1, 2, 3, 4, 5, doing what you need to do. Most of it is in discounted item. You'll see that discounted item is essentially a bunch of comments about what you're supposed to do. Now, I know some of you are going ahead, copying and pasting them in and compiling them and seeing errors. They will stop being errors once you compile and save all 4 of them in the same location. For example, if I were to go ahead and try to compile discounted item first, it's going to go, I don't know what item is, so it won't compile. You got to get all 4 of them in there and then compile them, and then it'll work. I promise. So you're mainly going to be adding to this discounted item class, and then when it's all good, you can go ahead and uncomment the 2 lines in shopping cart tester and check it out. So just one last time, if you're confused, which is okay, you're going to follow these instructions 1 through 5 here. Follow those instructions in JGrasp. Basically, you're only working with the discounted item class. And then you'll uncomment the code in the main method to test it. This is your assignment. If you finish it in the next 12 minutes, no homework. If you don't finish it, that is your homework. Now you guys, maybe I should pause the recording. So you guys are doing that, that's your assignment.